Okay. So we start with people quantum mechanical model of the atom. Last class where we stopped was Heisenberg's uncertainty principle. Heisenberg's uncertainty principle says that we cannot precisely determine both position and momentum simultaneously for subatomic particle, and this was a major limitation of Bohr's atomic model. Now we move ahead with what is known as the quantum mechanical model of the atom. Now, quantum mechanical model was given by Heisenberg along with someone called as Erwin Schrodinger. Now, Schrodinger gave us what is called as Schrodinger's equation. अब थोड़ा क्लास 11 के लिए वो इक्वेशन हैवी दिखता है. They won't really ask questions related to the equation, neither in mains, advance or JEE or NEET. इस पे related questions वो पूछेंगे नहीं. But just आगे, in order to really understand what do you mean by quantum mechanical या wave mechanical model of the atom, we should have थोड़ा सा idea. What you have on board, ठीक है, is an equation which can use to explain atoms. Not only explain atoms, it is something which can be used to explain electrons which are present in an atom. We can divide the equation into छोटा सा parts just to try to understand what exactly is given in the equation. This deba by deba x, इनको हम बोलते हैं partial derivatives. बेसिक मैथ्स में आपने डेरिवेटिव्स किया रहेगा डी बाई डी एक्स. पार्शियल डेरिवेटिव्स अभी नहीं है, बट येस इन इंजीनियरिंग फर्स्ट ईयर, इंजीनियरिंग सेकेंड ईयर, स्पेशली आईआईटीज में तो क्वांटम फिजिक्स तो काफ़ी हो जाता है मैथ्स में, तो आप तभी करेंगे. इसको हम पार्शियल डेरिवेटिव्स बोलते हैं. आप थोड़ा बहुत पार्शियल डेरिवेटिव्स 12th स्टैंडर्ड में भी करेंगे. पार्शियल डेरिवेटिव्स इज लाइक कीपिंग वन कांस्टेंट डेरिवेटिंग विद रिस्पेक्ट टू द अदर वेरिएबल. बेसिक अगर बोला तो एक्स वाई एंड जेड, you people can tell me ये x y z क्या होगा? These are nothing but the coordinate axis. That's a three-dimensional model. So x y z मतलब x axis, y axis और z axis. ठीक है? What you see here, this is called as phi. ठीक है? Phi is called as wave function, or this is also called as the amplitude of the wave. Since we are considering wave nature of the electron, this represents the wave function. Simple terms में what exactly is a wave function? हमने sin theta पढ़ा है, ठीक है? साइन थीटा का हमने जस्ट बेसिक वैल्यूज पढ़े हैं, राइट? दैट व्हाट इज साइन 0, साइन 30, साइन 60, साइन 90 एंड सो ऑन. इफ यू प्लॉट दैट, वो कुछ ऐसा दिखता है. यू कैन से दैट ये वेव फंक्शन बेसिक लेवल पे हम बोल सकते हैं दैट इज साइन थीटा. सो एवरी इलेक्ट्रॉन विल हैव समथिंग कॉल्ड एज इट्स ओन वेव फंक्शन. साई represents wave function. With me till here? Everyone knows what H is. What does H stand for, people? H को हम बोलते हैं Planck's constant. What is M? M is mass of the electron. Capital E stands for total energy, and V stands for potential difference. Now, This equation is not a derived equation. I repeat, Schrodinger equation को derive नहीं किया है, but एक equation form किया है. ठीक है? Not required for the current syllabus, but just थोड़ा सा basic knowledge about the equation. It's not a derived equation. ऐसा नहीं कि आप किसी एक point से start करके Schrodinger's ये equation तक derive करके लाते, नहीं. It's like a culmination of different properties. Now, whenever you solve an equation, you get what is called as its roots. For example, कोई basic equation दे दूँ, x square plus 4x plus 4 is equal to 0. What's the value of x over here?
minus 4 plus minus root.
यहाँ पे x का वैल्यू क्या है? 10th standard में क्या है? You find what do I put for x so that the LHS becomes equal to the RHS? If I put x is equal to minus 2, what do you get here? 4 plus 4 times minus 2 plus 4. How much is that? 0. X is equal to minus 2 को हम क्या बोलेंगे फिर? The root of the equation. I repeat. X is equal to minus 2 put करो, what you get is called as the root of the equation. Similarly, when you solve Schrodinger's equation, I repeat, when you solve Schrodinger's equation, you get what is called as the roots of the equation. Now, roots of the equations is something which is very important, जहाँ से हमारा syllabus start होता है. But जब हम roots को भी solve करते हैं, there are two ways to solve the root of the equation. एक हम बोलते हैं, this is normal, जैसे कि consider ये हमारे पास x axis, y axis और z axis है. Let's say in this classroom, let's say this is x axis, this here is y axis और इसको ऊपर कर लो z axis, and let's say some point here I can find the x coordinate, y coordinate and the z coordinate. तो ये point P है, इसका I can find x coordinate, y coordinate and z. These are called as Cartesian coordinates. Basic, I think basic maths में किया है आपने? Yes or no? But we also have something called as spherical coordinates or polar coordinates. The same x-axis, x coordinate, y-axis or z-axis, z coordinate can be determined in the form of something called as r, theta and phi. I repeat, just like P has x, y, z coordinates, P also has polar coordinates r, theta and phi. यहाँ पे you can find r, you can find theta and you can find phi. This is just basic geometry, people. This is, for example, this is theta. This is, if you look at this triangle, can someone tell me how can I find this using geometry? If this is hypotenuse, this is theta. Let's say I say triangle A, B and C, and this is R. How can I find AC? What is the formula for cos theta? Adjacent upon hypotenuse. What is adjacent? AC hypotenuse AB. Can I directly write R? So I can say AC is equal to R cos theta. Getting that? Similarly, that AC is nothing but the Z coordinate. So I can say this is R cos theta, which is your Z coordinate. Similarly, your X coordinate is R sin theta cos phi and R sin theta sin phi is your y coordinate. So किसी भी point को in space you can give it by x axis, y axis and z axis. x coordinate, y coordinate and z coordinate, you can also give that particular point in terms of its polar coordinates. The reason we are doing this is with reference to nucleus, where exactly the electron is was derived using these polar coordinates. ये वैल्यू को हमको पुट इन करना पड़ता है in Schrodinger's equation. And I repeat, when you solve Schrodinger's equation, you get roots. These roots are called as quantum numbers. These quantum numbers were obtained when Schrodinger's equation was solved. And ye quantum numbers are divided into three types. The first quantum number n is called as principal quantum number. The second quantum number L is called as azimuthal quantum number. And the third quantum number M is called as magnetic quantum number. So I repeat, when Schrodinger's equation was solved, we got three quantum numbers. यहाँ से ध्यान देना ज़्यादा ज़रूरी है because this is from where the syllabus starts. N or principal quantum number tells you the energy of the electron. ये सब points मैं दूंगा, but बाद में we'll write it in terms of theory. It gives you the energy of the electron. It tells you in which shell the electron belongs. Simple terms में, quantum number will tell you that JP's Academy is on the first floor of one apartments. That is what principal quantum number tells you. तो किसी एक atom में वो electron कहाँ situated है, कौन से shell में, is given by principal quantum number. The value of principal quantum number n starts from 1, 2, 3, 4 and so on, which in lower standards आप लोगों ने पढ़ा है as K shell, L, M, N and so on. Second quantum number, azimuthal quantum number, जिसका और दो नाम है, we also call it as angular momentum quantum number and we also call it as subsidiary quantum number. We'll write that later. Tells you in which subshell the electron belongs. What is the meaning of subshell? From an address point of view, subshell का मतलब है that 11th standard का class will be in room number 103. So N tells you that JP's Academy is on the first floor. L tells you there are 4 classrooms. In which classroom is the lecture going on? Getting that? Hypothetically, what I'm trying to do is, let's say I'm trying to find Suhavni. Suhavni is my electron. And I'm trying to find Suhavni ka position kya. So I need 3 quantum numbers. Suhavni ka. I need n, so I know that Suhavni is somewhere on the first floor. Then Suhavni is somewhere either in this part of the classroom or she is somewhere there in that part of the classroom. Third, acha, L ka value goes from 0 to n minus 1. Which means, if principal quantum number is 1, what's the value of L? 0. If principal quantum number is 2, what is the value of L?
1.
0 and 1. If principal quantum number is 3, what is L? 0, 1, 2. If principal quantum number is 4, 0, 1, 2, 3, so on and so forth. With me till here? Next, the third quantum number is M or magnetic quantum number. Magnetic quantum number gives me the orientation of the electron. Magnetic quantum number will tell me whether the electron is present along the x-axis or is it present along the y-axis, or is it present along the? In short, magnetic quantum number will tell me Suhavani is in which region. Is she present in the first classroom or is she present in the second classroom? Can I find the exact position where she is? No. I can only determine in which region, in which classroom is she sitting in. With me till here? However, there was a need for, there is one more point. The value of m goes from minus L to plus L. So if the value of L is 0, how much is magnetic quantum number? 0. If the value of azimuthal quantum number is 1, then what is magnetic quantum number? Minus 1, 0, plus 1. If the magnetic quantum number is 2, minus 2, minus 1, 0, plus 1, plus 2, and so on. However, these three quantum numbers couldn't define all the properties of the electron, and hence a fourth quantum number was introduced, and that is called as spin quantum number. ये हम बाद में और डिटेल में पढ़ेंगे why spin was introduced. And the value of spin quantum number is plus half or minus half. Plus half means the electron is revolving around its own axis in clockwise direction. Minus half means it's revolving in anti-clockwise direction. Plus half means sometimes it's also written as an arrow pointing upward, and an arrow pointing downward is for anti-clockwise. So the electron revolves around its own axis in clockwise direction and in anti-clockwise direction. Now these are the four quantum numbers which help us understand the atom and understand the electrons which are present. Chalo. So which are the four quantum numbers? सबसे पहला quantum number कौन सा था? Principal quantum number. Now the value of principal quantum number कहाँ से start होता है? 1, 2, 3, 4, and so on. Which is the second quantum number? Azimuthal quantum number. If the value of n is 1, how much is azimuthal quantum number? 0. If the value of n is 2,
0.
if it is 3, 0, 1, 2, and 3. Pardon me, 0, 1, and 2. And if it is 4, 0, 1, 2, 3, and so on. We don't have to go beyond this. Next. Magnetic quantum number goes from minus L to plus L. If L is 0, if L is 1, minus 1, 0, plus 1. If L is 2, minus 2, minus 1, 0, plus 1, plus 2. And if L is 3, minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. Once again, principal quantum number n tells me which shell the electron belongs to. It also gives me the energy of the electron. Azimuthal or angular momentum quantum number gives me the sub shell the electron belongs to. How many subshells do we have here? The first shell has how many subshell? 1 subshell. 0 doesn't mean 0 subshell. What 0 means is कि वो एक shell को number मिला है. How many shells are there in the second shell? How many shells are there in the third shell, fourth shell, and so on and so forth? L, can you give me all the values that we have obtained for L till now? L ka value is 0, 1, 2 and 3. Of course, it can be 4, 5, 6 and so on, but that is not required. 3 तक की the entire periodic table खत्म हो जाता है. Now, subshell. When the value of L is 0, we say that the electron is present in the S subshell. When the value of azimuthal quantum number is 1, we say that the electron belongs to the P subshell. When the value of azimuthal quantum number is 2, we say that the electron belongs to the D subshell. And when it is 3, we say it belongs to the F subshell. Special, partial, differential, fractional, ऐसा कुछ नाम दिया है हमको. So, which subshell is this when L is 0? S subshell. यहाँ पे S and P. यहाँ पे S, P, D. Fourth shell has these are the different subshells. F के बाद भी जा सकते थे. It's not required. G, H. बट हम कभी यूज ही नहीं करेंगे. कोई अगर क्वेश्चन आ जाएगा ऐसे ट्रिकी तो ठीक है, बट वी आर नॉट गोइंग टू यूज G, neither are we going to use H. Now, what does M give you? Magnetic quantum number क्या देता है people? Orientation. अभी से हम ओरिएंटेशन को एक और वर्ड बोलेंगे, orbital. From now onwards, orbit make orbit अगर ये word use भी किया, orbit is similar to orbital. And orbit and orbitals are region in space. ठीक है, they are not the orbits जो अभी तक बोर के मॉडल में सीखा था. How many orbitals are present, ध्यान से सुनो क्वेश्चन, in the S shell? 1. How many orbitals or orientation are present in the P shell? 3. How many orientations are present in the D shell? And how many orientations are present in the F shell? 7. I repeat. You can say number of orientations, or you can say number of orbitals. In the S shell, how many are there? How many orientations or how many orbitals in the P shell? 3. D shell? 5. F shell? 7. If I would have asked G shell? 9. Excellent. 9. With me till here? Each orientation, each orbital can hold 2 electrons. Each orientation or each orbital can hold. So how many electrons can there be in the S subshell? 2. How many electrons can be there in the P subshell? How 6? 2 plus 2 plus 2. How many electrons can there be in the D subshell? How many electrons can there be in the F subshell? Did you get that? वापस यहाँ पे how many electrons can there be over here in this shell? So I have a question. How many electrons in the second shell? 8. यहाँ पे how many electrons over here? 2. Over here, how many electrons in the third shell? 18. What about here? 2, 6, 10 and 14. Total this for me कितना आता है ये? 32. जो 10th standard में आपने पढ़ा है, how many electrons are there in a shell? इसका फॉर्मूला क्या पढ़ा था? 2n squared. That's exactly the same thing. यहाँ पे आपको मिल जाएगा. Number of electrons in a shell is given by the formula 2n squared. Did you people get that? बोलो रे, yes or no? So there are 2 electrons. One electron will have clockwise spin. या तो ऊपर का arrow बनाओ या plus half लिखो, doesn't matter. The other electron will have anti-clockwise spin. How will you write these 6 electrons?
3 will be plus, 2 will be
First orientation will have clock, anti-clock, clock, anti-clock, and then फिर से clockwise and anti-clockwise. सबके लिए बनाने की जरूरत नहीं है, but it's okay. Did you get that till here? So if I want number of electrons in any shell, क्या formula use करेंगे हम? 2n squared. Similarly, can someone give me the relation between L and M? If I want to find a relation between L and M, let me tell you what I'm trying to ask. This is the 0, this is 0. 0 मतलब one orientation. How if this is 1, or if I'm talking about P subshell, how many orientation are there in P subshell? This is 2, then this is
5.
So I can write a relationship is in something like this. I can say M, can I say that is 2 times L plus 1. For example, put L is equal to 3. 2 3s are 6 plus 1.
7.
Can I say there are 7 orientations over here? Yes or no? Or if I put 2 over here, so 2 2s are 4, 2 plus 1 5. 5 orientations. Did you get that? Yes or no? चलो एक बार फिर से recap. Can someone tell me the number of electrons in the D shell?
10.
Number of electrons in the D subshell, D orbital. So D. कितना orientations है? 1, 2, 3, 4, 5. Each orientation can have how many electrons?
2.
So 5 orientation, total number of electrons
10.
10. Number of electrons in the F subshell 14. All this is very important because we need to know how to write electronic configuration using this. So tell me, first shell में कौन सा subshell है?
S.
First shell में the subshell is S1s. Second shell में कौन सा subshell है people? So 2s. And which subshell is present? So 2p. Give me the third shell.
3.
3s and
3D,
fourth shell
4s,
and
4D,
and गो अहेड. इसके बाद क्या होता था?
5s,
Yeah, 5s, then 5p, 5d, 5f. और उसके आगे क्या और होना चाहिए पीपल? 5g. but even if you don't write 5g, it's okay. then इसके बाद क्या आएगा पीपल? 6s, 6p, 6d. एक और लिख लेते हैं, 7s. Whenever you're now writing the electronic configuration, the filling starts something like this. Electron first enters into 1s subshell. How many electrons can enter in the s subshell?
2,
Number of electrons 2. After 2 electrons are done, if there are more, the next set of electrons will enter into 2s. How many will enter into 2s? 2. Then the electrons enter into, how many will enter into 2p?
2,
6. p can hold 6 electrons. After 6 are done, next कहाँ पे जाएंगे वो?
3s,
How many in 3s? 3s पे fill होने के बाद they'll all go into
3p,
how many?
6,
But after 3p, the electrons go into 4s. 3p के बाद they're not going to 3d. Remember this. 3p के बाद they're going into 4s. How many will go into 4s? 2. Then 4s के बाद they go to, how many they go into 3d?
10,
10. After 10 are done, next will go to,
4p,
उसके बाद
5s,
4p में 6, 5s में 2. Then they go to, how many in 4d?
10,
Then 4d से
6,
how many in 5p? 6. And this cycle continues. This relation what we have here is called as Aufbau's principle. Repeat, it is called as, Aufbau is not the name of a person. Aufbau means filling order. I repeat, Aufbau's principle. वापस से, where will the first 2 electrons go?
1s,
1s. 1s के बाद
2s,
2s के बाद
2p,
2p के बाद
3s,
3s के बाद
3p,
3p के बाद
4s,
4s के बाद
3d,
3d के बाद
4p,
4p के बाद
5s,
5s के बाद,
4d,
so on and so forth. ठीक है? So the first electron, first 2 electrons पहले जाते 1s. Then 1s के बाद we have 2s. 2s के बाद we have, then we have, after 3s, then we have 4s, and then 3d. Then we have 4p. Then we have, and then we have, and so on. Using this, we write new type of electronic configuration. Now you will no longer, if I ask you the configuration and say what's up 2,3 and 2,5 and all that. अभी से एक नया set of electronic configuration लिखते हैं. Extremely important because the electronic configuration gives you almost all the data which is required in organic chem में just the electronic configuration. Let's start with the first element. सबसे पहला element कौन सा है people? Hydrogen. Atomic number 1. Give me the electronic configuration for hydrogen. 1s. एक ही electron है. That electron is going to go to. So the electronic configuration is 1s1. Second element, helium. Atomic number 2. Both the electrons will go into. So configuration क्या हो जाएगा? 1s2. Next element. Atomic number. जल्दी से. Where will the first 2 electrons go? Can I write 1s3? Why?
Only 2 electrons.
So हम लिखेंगे 1s2. 2 चले गए. How many are left? वो कहाँ पे जाएंगे? So 2s1. Next, lithium के बाद atomic number. Please fill this for me. First 2 electrons into 1s. फिर are you people getting that? Chalo. Can someone give me fluorine? How will you write the electronic configuration for fluorine? 1s2. So out of 9, 2 चले गए. How many are left? 7. So 7 में से the next 2 will go to 2s2. How many done? 4 and 5 left. 5 के 5 can go into. Why? Because 2p can hold. Anyone who did not get this? Sure. Anyone who wants to try for neon? 1s2, 2s2 and 2p6. With me? Can someone give me the next set of elements? Sodium, and then argon. यहाँ पे लिख दो. चलो ठीक है. पोटेशियम, कैल्शियम. चलो आज के लिए 30 पे एंड करेंगे. चलो. Can someone give me aluminium? 1s2, 1s2, 2s2. आगे
2p6, 3s2, 3p.
and that is aluminium. Now the entire thing लिखना every time becomes tedious. So what we do is, if you look at the initial configuration यहाँ पे 1s2, 2s2, 2p6, that configuration is similar to the configuration of neon. So instead of writing the entire thing, we can simply write neon 3s2, 3p1. How will you write silicon? Neon
3s2, 3p2.
sulfur,
Neon 3s2, 3p3.
so on and so forth. Argon will write the entire thing. Argon क्या लिखेंगे हम people? Can someone give me the entire configuration of argon? Atomic number 18, 1s2, 2s2, 2p6, 3s2, 3p6. That's the configuration of argon. Now, can someone give me manganese? Atomic number 25. If I directly write argon, how many electrons are done? Argon is 18. So 18 हो गए. 18 minus 25. How many are left? But after 3p, where will you put the electrons? 4s. कितने electrons in 4s people? So 4 S2. 18 plus 2, 20. How many left?
5.
3D5. Getting that? Now, for write all the configurations, बाद में ना क्रोमियम एंड कॉपर के बारे में हम थोड़ा एक्स्ट्रा पढ़ेंगे. आपको जो कॉन्फ़िगरेशन मिलेगा यू पीपल राइट दैट डाउन, बट फॉर क्रोमियम एंड फॉर कॉपर देयर विल बी अ स्लाइट मॉडिफिकेशन. Any questions here, anyone, regarding how we write the new type of electronic configurations? समझा ये? चलो. Please write down a new page. The quantum mechanical model. The quantum mechanical model of an atom. The quantum mechanical model of an atom. Quantum mechanical model of an atom. Newtonian mechanics. Newtonian mechanics. NEW. Newton और IAN लगा दो. न्यूटन के आगे IAN. NEWTON. IAN. Newtonian mechanics fails when applied to microscopic objects. Fails when applied to microscopic objects. Such as microscopic objects such as electrons, atoms, molecules, etc. Because these particles have both. Because these particles have both observable wave-like and particle-like properties. Observable wave-like and particle-like properties. And hence, in order to explain the behavior of electrons, quantum mechanics was developed. Quantum mechanics was developed by Heisenberg and Schrodinger. Heisenberg and Schrodinger. 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 Heisenberg and Schrodinger. The Schrodinger's wave equation, for the wave motion of an electron. The Schrodinger's wave equation for the wave motion of an electron. The wave motion of an electron in an atom in three-dimensional space. In an atom in three-dimensional space. Now copy this page, sub data likho, and then we have to write some more points about wave function and probability density. Please write down important features of quantum mechanical model. The wave function psi, the wave function psi for an electron, the wave function psi would Trishul.
So is it called
Phi or
phi
psi?
or psi?
Phi.
So it's there.
Phi लिख दिया क्या मैंने? Pardon me, I'm so sorry. Psi. The wave function psi for an electron represents an atomic orbital in an atom. Atomic orbital in an atom. Since many wave functions are possible, there are many atomic orbitals in an atom. There are many atomic orbitals in an atom. And in each atomic orbital, the electron has definite energy. Full stop. Continue, same point. An orbital cannot contain more than 2 electrons. So let's understand what point क्या बोल रहे people. See, each orbital, अभी we have learned, जैसे कि in the first shell we have 1s, second shell we have 2s, 2p, third shell is 3s, 3p, 3d, and so on. Each of these orbitals have its own wave function. This is psi of 3s, 1s, so on and so forth. They have their own wave function. So we'll not learn them in detail. Later, probably third or fourth lecture, we will also learn thoda sa questions on these wave functions. Getting that? And each orbital can hold how many electrons? It can hold only 2 electrons. And electron spin also plays a very important role, that clockwise spin and the anti-clockwise spin. Next point, right on. Preferably if you have a red pen, different color pencil ko ye point ko. The probability of finding an electron at a point, I repeat, the probability of finding an electron at a point, finding an electron at a point within an atom, finding an electron at a point within an atom is proportional to people square of the wave function. You either write the entire thing or just write down psi square of the wave function which is also known as probability density. Which is also known as probability density. We'll learn more about this as we progress. Probability density. You can come back to a normal pen. Next point. Next point, third point. Physically, psi Trishul, physically psi represents the amplitude of an electron wave, the amplitude of an electron wave at any time, full stop. Continue. Just in case of a light, just as in case of a light, the intensity of light wave, just as in case of a light, the intensity of light is proportional to the square of the amplitude, of the wave Similarly, in case of electron wave, the square of a wave function red pen, the square of a wave function red pen determines the intensity of an electron, at that point, or probability of finding the electron per unit volume. Probability of finding the electron per unit volume in a given region of the space, around the nucleus. Back to normal. This space where the probability of finding the electron is maximum, where the probability of finding the electron is maximum, probability of finding the electron is maximum, is known as orbital. Probability of finding the electron is maximum is known as orbital. ठीक है, चलो, you can continue copying. Okay, चलो, let's write थोड़ा सा theory points for all the quantum numbers. First one is principal quantum number. We'll just write keywords. Represents shell. Principal quantum number represents shell in which the electron belongs. Next point, gives an approximate position and energy of the, नहीं सब principal का ही लिख रहे हैं, gives the approximate position and energy of the electron, approximate position and energy of the electron. Next point, as n increases, the distance of electron from the nucleus will also increase. As n increases, the distance of electron from the nucleus also increases. And people, what was the formula for maximum number of electrons in a shell? 2n square. Please write down maximum number of electrons in a shell. Maximum number of electrons in a shell is 2n squared. ठीक है, this was all for principal quantum number. Second, write down azimuthal or azimuthal or azimuthal के लिए एक और नाम है orbital angular momentum quantum number. Or subsidiary quantum number. Subsidiary quantum number. ठीक है, first point represents subshell. Represents subshell. एक और पॉइंट लिख सकते हैं, also gives the energy of the electron, also gives the energy of the electron. Next point, what's the relation between L and N, principal quantum number, and azimuthal quantum number? We can write L is equal to 0 to n minus 1. ये point अगर लिखा है तो ठीक है, नहीं लिखा है तो please write this again. L is 0 to n minus 1. Then एक दो line छोड़ना, because we have to then write a formula of orbital angular momentum, but when we reach that stage तभी वो formula लिखेंगे. तो leave around 2-3 lines. मतलब ऐसा आपको लिखना है, orbital angular momentum is root of L into L plus 1 upon h bar, but अभी दे नहीं रहा हूँ formula. When we do it, तब के लिए आपको formula वहाँ पे भी add करना. Next, write down the third quantum number, which is,
We have to write the formula.
no, just leave some space for the formula. Then please write down magnetic quantum number. So what does magnetic quantum number represent, people? Possible orientations. Possible orientations. Next point. M is equal to minus L2 plus L, like the relation between magnetic quantum number and azimuthal quantum number. M is minus L2 plus L. Each value of M, each value of M represents, each value of M represents one orbital. Each value of M represents one orbital in the given subshell. In the given subshell. And the total number of orbitals, in a given subshell, total number of orbitals in a given subshell. The formula is on the board. So for example, people, if I want P subshell, what will I put in place of L, because it is P subshell? Remember, SPDF. What is the value of azimuthal quantum number for S? For P?
0, 1.
So if I want for P subshell, to 2 into 1 plus 1, there are how many orientations in P subshell? 3. How many electrons in P subshell? 6. So next, write down number of electrons in a subshell. Can someone give me a formula for that? Number of electrons in a subshell. If number of subshell is 2l plus 1, we know that.
4L plus 2.
Excellent. 2 into 2l plus 1. Number of electrons in a subshell is 2 into 2l plus 1 या 4l plus 2 भी लिख सकते हैं. Excellent. Good. People, if I consider shell number 1, how many orientations? Shell number 2, how many orientations? Shell number 3, how many orientations? कितना होता है टोटल ये? 9. Fourth shell. So number of orientations in a shell in terms of quantum number n is n squared. Can I say that? Please write that. Number of orientations or number of orbitals. Number of orientations बोलो या number of orbitals in a shell is equal to n squared. ठीक है. Last quantum number was spin quantum number. Was spin quantum number given by Schrodinger? No. ठीक है. So सिर्फ लिख दो not given by Schrodinger. Not given by Schrodinger. And has two values, plus half, minus half. Two values, plus half, minus half. Or an arrow pointing upward, arrow pointing downwards. इसके बाद भी leave around 3-4 lines. We have to write a formula for spin angular momentum, but वो जब पहले we'll understand what that really means, उसके बाद हम लिखेंगे उसका formula. So 3-4 लाइन उसके बाद भी छोड़ के रखना. ठीक है. I want you to then copy this. इसके ऊपर this is Aufbau's principle. Aufbau's principle पे थोड़ा theory बाद में लिखेंगे. And then by next class I want you to write all the electronic configurations. ज़्यादा नहीं है, just from first element to zinc, which is atomic number 30. So से 1 to 30 मांग रहा हूँ. उसके बाद भी लिखना है eventual 54 xenon के बाद even in Aufbau's principle बहुत सारे exceptions आने लगते हैं, but वो सब शॉकर में बांध में देना चाहता हूँ. Initially इतना ही पढ़ लो तो भी काफ़ी है. Next this is just we've just completed 20% in terms of 30% in terms of the wave mechanical model. आगे Hund's rule करना है, Pauli's exclusion principle, n plus L rule, probability distribution curves and all that. It should probably take us 2 more lectures to complete this. ठीक है? So I will see you people next class.